Hello everyone, my name is Oorja. Welcome to DhiNexus. Today we'll be learning about aryl halides and their methods of preparation as well as chemical properties. We at DhiNexus try to make learning simple, engaging and clear. So stay tuned till the end of the session. What all topics will be covered in this particular video? We'll be having a look at formation of aryl halides via two routes: direct halogenation and diazonium salts. So these are the two main reactions that are given. Nucleophilic substitution reaction, electrophilic substitution reaction, reaction with metals, and in that we'll be having a look at Wood's fatigue and fatigue reaction. So who should watch this video and for whom will this video be helpful? Anybody who's preparing for their school exams, school board exams, uh, students who are appearing for ITJ or NEET exam or any other entrance exams, this is the foundation chapter. Aryl halide is an important class of organic compounds. So let's get started. So first we have methods of preparation. In this, direct halogenation is what we'll be looking. So what do we understand by halogenation? It is nothing but the reaction with X2. Here we have two types: nuclear halogenation or directly on the ring. This is side chain halogenation. Side chain halogenation which takes place, that is not exactly aryl halide, but it is called aryl halide. If I have this CH2X, this is called aryl halide. So you should not get confused, even though we're studying it right here. We're not going to get confused by this. Let's look at the first. We take first benzene, which is C6H6 along with Cl2 under anhydrous conditions. Anhydrous means there's no trace of water along with FeCl3. FeCl3 is a Lewis acid. In place of FeCl3, I can also take FeBr3 or AlCl3 and so on. This works as a halogen cap. In CBSE 2025 exam, or if I'm not wrong, CBSE 2024 board exam, this question was asked: which one is the halogen carrier? And it provides us with Cl minus ion. At 310 Kelvin, we will be getting a chlorobenzene. Chlorobenzene is my aryl halide. So aryl halide is the one which is directly on which ring has a halide. So I will get HCl as a bihalide. Second is the side chain halogenation. So what is the common name of this compound? This is famously called as toluene. Please try the IUPAC name. This is called methyl benzene. If you look at it and if you are able to recall, something like this is studied in 11th grade, where we're trying to prepare alkanes. So in alkanes, we directly react to the halogen in presence of sunlight. So this can be either sunlight or it can be photolight at 383 Kelvin. What I get is a benzyl chloride. This is the name of this compound. This is benzyl chloride. That's the common name. And let's see. Please note that just like the preparation of alkanes, this one is also a free radical substitution reaction. Moving on, we have preparation with diazonium, an important class, highly important, and this is used in preparation of a number of other compounds, like we'll just see. So how is it? At first, I take aniline. Aniline is a common name of NH2 present on benzene. Another name or IUPAC name is benzene. However, aniline is also accepted by the IUPAC nomenclature. Along with NaNO2 and HCl at 025 C, I get N2 plus NCl. This together is known as HONO or HNO2, which is nitrous acid. So it is actually the nitrous acid that is helping us prepare what? Benzene diazonium fluoride. Like I already said, benzene diazonium fluoride can be very useful. So let's see what all does it help us prepare. So let's take a blank slide. At first, I will react it with Cu, that should be it here, Cu2Cl in presence of HCl. What I get is a chlorobenzene. This is called the Sand-Mears reaction. You can also prepare bromobenzene by this method. What is the name of this compound? It is called Sand-Mears reaction. Modification of this is Gattermann reaction, where I just take copper dust with HCl. I will get the same compound, chlorobenzene. I can take bromobenzene and I can still get that. This is called Gattermann. This is Gattermann reaction. If I just add Ki and boron, then I get iodobenzene. This is the best method known for preparing iodobenzene, one of the best methods. If I take it with HbF4, with HbF4, I also take slightly room temperature and I heat it. This is our temperature. I get fluorobenzene. This one is known as Baz-Scheme reaction. N2Cl can also find number of other uses as well. Suppose if I just reacted with water and one, so it can be used to prepare phenol as well. But we'll see about that more in the next chapter, which is alcohols. Right? So this is how we prepare iodobenzene, fluorobenzene, chloro and bromobenzene. Just to reiterate here, we must know that this method, the direct hallucination, is best for preparing chlorobenzene and bromobenzene. Iodobenzene, these are known to show reversible reaction, and fluorobenzene is highly explosive. So we do not prepare it via this method. We can, however, prepare it via benzene diazonium fluoride. Moving on, let's start with the chemical properties. So aryl halide are known to show nucleophilic substitution reaction, electrophilic, and reaction in. However, nucleophilic substitution reaction, aryl halides are known to be highly less reactive when compared to alkyl. The reason for this low reactivity is the fact that my chlorobenzene, for example, it can undergo resonance. So because of resonance, there is a formation of a partial bubble. How does that resonance take place? This is chlorobenzene. Now, chlorobenzene is known to be ortho and para-directed. So this one should have I will get a positive charge here and a double charge. Now, because this bond was also, it's actually here, this one, so I get a negative charge. And there is a charge delocalization that takes place. So now the negative charge comes at the para position. Nothing came at the meta position, as you can see. Again, at the ortho position. So now what do I get? I get this side, the one here, and finally the bonds resume. So this is what I get. As you can see on position, so this, and this, we are seeing carbon chlorine double bond. There is carbon chlorine double. Now, double bond is known to be shorter as compared to a single bond, as well as it is stronger. The bond is strong. So this carbon here becomes sp2 hybridized. This is sp2 hybridized as well. Right? So because of that sp2 hybridization, the electronegativity increases and so does the bond strength. You already saw. Why does that happen? Because in comparison to sp3, the sp2 has more S character. The S character in this case is 33%. Here, however, it is only 25%. So the electrons are embedded closely with the S subshell and they are not readily given. Third is the less susceptibility of Aryl Halides towards SN1 and SN2 mechanism. Reason being, the phenyl cation is unstable. It cannot exist on its own. So it prevents the formation from SN1 reactions, and aromatic ring also blocks the backside of nucleophilic substitution reaction, which is required for SN2. So that is not feasible, neither SN1 nor SN2. One more point that I would like to highlight is that aryl halides are already dense with electrons. They have high electron density. So they will show some repulsion in case a nucleophile, which is also packed with high electrons. So it will cause a repulsion between nucleophile and the aryl. Hence, that is not feasible, and aryl halides are very less reactive towards nucleophilic substitution reaction. However, we have still seen that there's one reaction very famously known as Dawes process. There are more reactions, but according to NCRT, this one is what we study. When I take chlorobenzene along with NaOH at 623 Kelvin and 300 atm. atm is the unit of pressure. So at very high temperature and pressure, I get a feed. It is also observed that if I keep increasing the number of electron withdrawing, suppose I add one here, NO, plus NaOH, then what I see, what will be observed is that the conditions become very mild. For example, this can be done at 443 Kelvin, and the condition for, yes, so it becomes doable at 443 Kelvin with some dilute acid. Here also we take some dilute acid. And suppose I increase more number of nitro groups. Now I add the para positions. So what I'll see is aqueous NaOH is enough along with 368 Kelvin and dilute. So you can see that the trend is that the conditions are becoming milder. So NO2 will obviously retain its position. And one more thing that we observe is one reaction is a second. So we just do it here. If the nitro group is added at all the ortho and para positions. So this would increase the reactivity even further, and it can be done at H2O, just H2O at 323 Kelvin, yielding us trinitrophenol. This trinitrophenol, this is called as commonly picric acid. Please note, it is called as picric acid. So wherever you find any name reaction, always remember to note down its point. Its name very important. So moving on, we have we will next be looking at the electrophilic substitution. So we'll do that here. Electrophilic substitution reactions, in this case, there is formation of, there are a total of 5 electrophilic substitutions that we'll be having a look at. So first will be, in this case, halogenation. So already in case of already a presence of halogen is there and one more halide will come. So what is the process? I take chlorobenzene and anhydrous FeCl3 along with. Now, what is FeCl3? Like we've already covered, that is FeCl3 is a Lewis acid, and this along with Cl2 gives me another ortho and para isomer of chlorobenzene. So this is a dichlorobenzene that I discussed. Which one is going to be the major? The major will always be the para. The reason being, this has the least steric hindrance. Second is the formation of or like introduction of nitro. This is done via nitration. So again, suppose I take C6H5Cl along with HNO3 and H2SO4. Both are in concentrated form, and I heat them. C6H5NO2 is which? One of them will be ortho and one will be a para isomer. The para isomer, just like we had Cl here, I will introduce NO. Next is the formation of sulfonation. So sulfonation and Friedel-Crafts reaction is what will develop. So sulfonation introduces SO3H. Chlorobenzene on reaction with H2SO and heating gives us something like this. Please try to name it by pausing the video once. This should be 2-chlorobenzene sulfomic acid. Along with the para isomer. And lastly, Friedel-Crafts reaction. Friedel-Crafts shows two types of reactions, alkylation and acylation. So alkylation introduces the alkyl group. It could be CH3, C2H5, anything. And this is acylation. The acyl group introduces CO, CH3, and so on. C8, what that's like. Done in the presence of chloromethane or acetyl chloride, so also known as acetylation. This is the formation of 1-chloro-2-methyl-benzene. And second, which is as acylation, I will just take CH3COCl, also known as ethanoyl chloride. So do remember to note all the extra names that we're studying, whatever because you never know what they will ask you in the exam or which name have they used. So it is crucial to use all. I forgot to mention, you will put anhydrous FeCl3 in both. N neighbors of the CH3 along with neighbors of CH3, or you can take FeBr3 as well. Both are Lewis acids. And COCH3. What is the name of this compound? This is 2-chloro acetophenone. Was COCH3. So basically, this is RCOR. RCOR we know is the common name of E compound, along with the para-isomer. The para-isomer will be drawn at all of these pieces. Then is the formation of Wurtz reaction or Wurtz-Wittig reaction that we'll just see right now. So just like we have done in the alkyl halides, here also we'll see reaction with. This is actually the third type of reaction with metals. The Wurtz-Wittig first. So one of these will be an aryl halide along with Na, and one will be CH3. So there will be elimination of this. I'll just remove this, and what I get is a toluene. CH3 along with, of course, dry ether in presence of sodium. This was Wurtz-Wittig. Wurtz because we have taken alkyl halide, and Wittig because we take aryl halide. If I'm taking two aryl halides, suppose I am taking two aryl halides, then I will be getting a biphenyl. It can also be called as a diphenyl. So in dry ether, the formation of biphenyl. This marks the completion of aryl halides. We've covered both chemical properties as well as the methods of preparation. This is comparatively in this reaction, in this particular group, the number of reactions were less, but this is also very important class, and number of questions, a lot of number of questions have been asked. If you